Good afternoon, everyone. First of all, let me apologize for not making a video last week. We had to head up to the Huntsville area, and we needed to be there by as soon as possible, so I had to leave school right after in order to get there. But anyway, enough of that. I will be out Thursday and Friday. I'm going to be observing a local school to see how they teach math tomorrow, and then we got a doctor's appointment Friday. So I'll be out the next couple of days. But what we've been talking about is still the same. We've been working on 1-digit by 3-digit multiplication problems, and we've been working towards getting away from the base 10 blocks. We're working towards simply writing things as equations. So this is an area model. If you'll remember back to when we were doing our arrays, we went, well, I'll use this pencil. Let's say we had a 3x4 array. That's always the one I go to. We would have 3 over here because we had 3 rows. 1, 2, 3 rows. And depending on how many columns we have, 1, 2, 3, 4, we would write our amount here. But there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the whole array. So then this represents a 3x4 array, or can be represented by the multiplication problem 3 times 4, which equals 12. Then we stripped this away, and we just started using what was called an area model. And so we had a length of 3, we had a length of 4. The multiplication problem that represents this is 3 times 4 equals 12, and that is what we were working towards. But we are now working with 1 by 3-digit multiplication. So rather than it being just 1 by 1, it is 1 by 3. Let me zoom in, and let's get down to it. All right, so I can't remember if it was last week or the week before, but we actually got out, yes, I did that, okay. We got out base 10 blocks, and we made these area models. If it said 184 times 6, we literally made area models using the base 10 blocks. We would make 100 with 100, and then we'd get 8 tens and 4 ones, and we would recreate that 6 times to make 6 groups of 184. Well, after that, we started representing that. So 184 would be represented like this. There's 100. 1, 2, 3, 4, 5, 6, 7, 8 tens and 4 ones. We want to represent this 6 times, but we want to do it in a way that is nicely organized so that we can quickly find the answer without having to do a whole lot of regrouping or anything. So I'm going to put all my hundreds over here. Well, since I'm doing 184, I'm going to write that in expanded form as the lengths of each of these sections, or as the amount that is in each section. So if I take 184, I'm going to split it into 100 plus 80 plus 4. But I am doing it times 6, so that means I have 6 groups of this. So over here, I'm going to write 6. So if we think back to our array, this would be an array of 6 groups of 100. We'd have 6 rows with 100 columns. Here, we'd have 6 rows with 80 columns. Here, we'd have 6 rows with 4 columns. And so the way that we could write that would be 6 times 100, 6 times 80, and 6 times 4. And that's what we're working towards ultimately. But before we got to that, we actually represented this. So we have 6 groups of 100. So I'm going to actually draw 6 100s blocks. And again, we would have represented this with actual base 10 blocks first, but this is 100, 200, 300, 400, 500, 600. This is 6 groups of 100. Here I need 6 groups of 80. Oh my gosh, I wish I had not chosen this, but here we go. 1, 2, 3, 4, 5, 6, 7, 8. That's one group. 1, 2, 3, 4, 5, 6, 7, 8. Another group. 1, 2, 3, 4, 5, 6, 7, 8. That is my third group. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 1, 2, 3, 4, 5, 6 groups of 80. Here we're going to have 6 groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is actually a representation of 6 groups of 184. And now, at this point, the students who are using the base 10 blocks, they can actually count all this. So we have 1, 2, 3, 4, 5, 6, and each of these are hundreds. So they could count 100, 200, 300, 400, 500, 600 to find out that there is a total of 600 in this box. Then they could actually count these tens, and believe it or not, some of the students do actually count the tens. But I'm going to talk about this later. This is where we're really having the biggest issues. Everybody's setting up the problem well. Everything's labeled correctly. They might even draw the base 10 blocks correctly, or if they've moved on beyond that, they're just writing the equations, but it's all correct, except we're struggling with how to get the correct answer, particularly in the tens place. So we'll talk about that in just a second. But here we have, they can count one by one, but I'm just going to speed up the process. So we have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So we should know 6 times 8 is 48, but they can actually count them. So anyway, we have 48 tens. Some of them will want to write 48 and just let that be it. But this isn't 48. This would be 48 if it was 6 groups of 8. But since these are tens, we have 10 times 48. And since it's a 10, when we write 10, we have a 0 in the ones place, and 1 is in the tens place. So this 4 and 8, it's not just 48. We've got to have a 0 in the ones place just like a 10. So it's 480, a value of 480. Okay, so that is the area of that section, and then we have 6 groups of 4. 4, 8, 12, 16, 20, 24. So there's an area of 24 in this section. Now, I'm going to scratch this out and just use this to show what we're actually headed towards. So this would be, again, the representational version of this. Well, let me solve it first. So now we want to add each of these areas. So 600 plus 480, that gives us 1,080 plus 24. That is going to give us 2,004. Let me think about it. Yep. 600 plus 400 is 1,000. 1,000 plus 80 is 1,080 plus 20. 2,000 plus 4, 2,004. So the answer would be that there were 2,004 bicycles produced in total in 6 weeks. Now, I'm going to redo that down here, but without drawing the base 10 blocks. This is ultimately what we want the students to work towards this year. And ultimately, even more, in the future, I think 6th grade, they will move away from even the area model, and they'll just go to the standard algorithm. But for now, what we're trying to do is build an actual understanding. Like, for example, here, it's not 48. It's 480. It's a value of 480. So if they were, the people who have been adding this, they're doing 600 plus 48 and getting 648 plus 24. So you get 668, 672. 672 and 2004 are way different. So we want to make sure that they're actually understanding these are tens, not ones. So anyway, for this year, we want them to be able to set up the area model. So again, 184 times 6 is the problem we're doing. So we have 6 groups. We break 184 into 100 plus 80 plus 4. But instead of drawing all this stuff, because next week we're getting into thousands, and so we're not going to want to draw 6,000s and 400s or 4 groups of 600 or whatever. It just gets to be a whole lot of work. So what we want to do is we want to write numbers that represent those pictures. So instead of drawing 6 groups of 100, I'm just going to write 6 times 100, because it literally means 100 6 times, or 6 groups of 100. Well, if they need to count at this point, they can go 100, 200, 300, 400, 500, 600. But hopefully we should just know 6 times 100 is 600. Here, instead of drawing all of these tens, which you saw me do it took a while, instead of doing that, we can write an equation that describes that picture. 6 groups of 80. Here is where the math facts really need to come in. The students are really struggling with their 8s and their 9s particularly, so if you get a chance to practice multiplication facts, basic facts, get the 8s and 9s, because that's our biggest advice right now. But if we know that 6 times 8 is 48, we can go ahead and put that down. But then we realize that this is not 6 times 8, it's 6 times 8 and 80, or 6 times 80, and 80 can be written as 8 times 10. Anything that we multiply times 10, we're going to shift it one place to the left on the place value chart, and we have to fill in the ones place with a 0. So basically, multiply by 10, put a 0 at the end. Okay? It even rhymes. It's nice. But and for some reason, the students are just not getting it. But even if they are getting to add a 0 here to show that it's been multiplied by 10, we're still getting all sorts of answers that are not 48. We're getting 36, 32, 35, 37, anything but 48. So make sure we know our 8s and 9s. So 6 times 80 gives us 480. Now over here, we have 6 times 4. And again, if we know our math facts, we have 24. If we don't know our math facts, we can do other strategies. Like if you know, say 6 times 2 is 12, well, you can double that. 6 times 2 is 12, 2 times 12 is 24. Or we could do 6 times 5 and then take away 6. If you know 6 times 5 is 30, take 6 away from that, you have 24. Or you can count by your 4s, 4, 8, 12, 16, 20, 24. Lots of different strategies we could use, or even 4 times 5 is 20, plus another 4 would give us 6 groups of 4 is 24. Anyway, we want to add all these together. 600 plus 480 plus 24 equals 2004. And so compare these. How much writing there is here versus here. And I'm trying to show the students that this is so much more efficient. I do think that there are some students who kind of still need this as kind of a crutch to move towards this. But ultimately, this is what we want to be doing by the end of 4th grade. And honestly, before Christmas. So, if you would like to practice some of this at home, this is an example of how to do that. I have a few more options here, and you could make any word problem you want to with a 1 by 3-digit multiplication problem. Honestly, I hate it, but I used ChatGPT to come up with the contexts for these, and it saves a lot of time. So if you just type in, give me a 1 by 3-digit multiplication problem in word form, or a 1 by 3-digit multiplication word problem, it'll pop one up for you. You don't even have to think about what the context is. So, like I said, hate that I stooped so low to do that, but it saves some time. All right. The other day, I gave them a formative assessment, and the math coach and I, Mrs. Stocks, we went through and we kind of checked through all these to see how the students were doing. A formative assessment, again, is not a graded test. It is just a test that sees where students are and helps us decide on next steps. Well, based on the next steps from this, like I said, we really need to work on multiplying by our tens and hundreds, and then we just need to focus on basic math facts, and then we need to work from going from this to this, taking out the base 10 blocks altogether and just thinking abstractly. What the students had to do here is they had to read the word problem. The school library orders 428 new books for each grade. There are 6 grades. How many new books are ordered in total? Show your work by using the area model. Write the expanded form equation and the standard form equation that matches the story problem. So basically what this is saying is just make an area model. Since we know that it is a 3-digit and a 1-digit, we know that we need 3 sections. We need a ones section, a tens section, and a hundreds section. Well, now we know there's 6 grades, so those are our groups. We're going to have 6 groups. We're going to take 428 and break it into expanded form. 4 is in the hundreds place, so 400. 2 is in the tens place, so 2 tens are 20. And 8 is in the ones place, so 8. When we add those together, we get 428. Now, again, this is like our rows and columns. We have 6 groups of 400. So we write 6 times 400. If we know 6 times 4 is 24, we can write that. Well, here, we got a lot of 240. Same thing as the tens, though. 400 is just 4 times 10 times 10, because 100 is 10 times 10. And each time we multiply by 10, we've got to shift the whole number to the left one place on the place value chart and replace the ones place with a 0. So if we have done that twice, we've got to replace not only the ones place, but also the tens place with a 0. So, in short, multiply by 10, put a 0 at the end. Multiply by 100, put 2 zeros at the end. So 6 times 4 is 24, but we've got 2 zeros over here in the 400, so we need one more 0. 6 times 400 is 2,400. Or we can think of it as 24 hundreds, because if we have 4 hundreds 6 times, that if we were to count every single hundred and not change to thousands, there would literally be 24 hundreds, and you write 100 with 2 zeros. So 2400, otherwise known as 2400. So make sure we are putting enough zeros to represent the actual number. So once they did that, they had 6 times 20. They need to write these equations. These are the expanded form equations that this is referencing here. The 6 times 400, the 6 times 20, because 428 is written in expanded form, and we're multiplying it by 6. So then 6 times 20, we think of 6 times 2 is 12, but it's times 10, so 12 times 10 is 120. 6 times 8, write the equation, and we have 48. Now we need to add these together. There's absolutely nothing wrong with a student coming over to the side and setting this up in standard algorithm, as long as they are remembering to line up the ones with the ones, tens with the tens, hundreds with the hundreds, thousands with the thousands, line up by place value. We have 8, we have 6, we have 5, we have 2. 2,568 is our answer. So after that, they would need to write that this whole thing represents 6 times 428, and that its product is 2,568. So 2,568 books, new books, are ordered in total. That was their formative assessment. Today and tomorrow, they're going to finish it up. We did a cut and paste activity. So the students were given 3 sheets. They have 1 through 5 is 1 by 2 digit multiplication. 6 through 8 is 1 by 3 digit multiplication. There we go, it focused. And they're given an empty area model that they have to fill in. So they were supposed to come in here and fill this in with pencils. So they would set up, we have 5 groups here. We have 48 split into 40 plus 8. 5 times 40 should be written in here. 5 times 8 should be written in here. And then solve it. 5 times 4 is 20. And a lot of students are stopping there. But remember, this is 4 times 10, so we got to do 20 times 10. So 200, not 20. And then 5 times 8 is 40. And I've got people doing 37 and 36 and 48 and all sorts of stuff for 5 times 8. We need to know those math facts. So then we add 200 plus 40, and we get a total of 240. But they also received a sheet like this. There are 8 problems that they had, and there are 36 options on here. There's only 2 spaces per each of these 8 for them to paste anything. So that means there's 20 answers that are not correct here. Over here we have our products. So once they find the product, they're going to find it over here. We had 240. So the student should cut this out, and then they glue it next to the area model where it says product. So we have our product, and then they're going to find their expanded form equation, which is right here. They already wrote it, 5 times 40 and 5 times 8. So we're going to look for that in our groups. There's 5 times 4 and 5 times 80, so that's one that's thrown in there to trick them, but it would not be correct. If they were to put that, it wouldn't be correct. So here it is, 5 times 40 and 5 times 8. They would cut this out and paste it in here next to it. If you would like to do some extra practice like this at home, these are some ideas that you can do for practice. If there are any questions, like usual, don't be afraid to reach out. I will do my best to get back to you as quickly as possible. Thanks for letting me teach your students. Y'all have a good week. Good rest of your week.